Everyone will be starting on the Encrypted Pastebin, which is going to be fun. And while it starts, let's see. Okay, we can see is a form that is accepting a title, test, whatever. And if I do a post, it gets it. And we have like some kind of URL for that one specifically, which is then encoded and all. So let's do some checks now. Quickly looking at the source code here and here, nothing. We developed the most secure pastebin on the internet. Your data is protected by AES 120 bits, 28 bits. The key for your data is never stored in our database, so no hacker can ever gain access. Let's prove them wrong. So as you saw, the first one is actually going with a post, and what happens if we dummy the post? Guess what? We have our first flag, which is showing at the top. Congratulations. And this is a valid flag, and of course I already flagged it. So what we could see also is that it's decrypting the link, and using a lambda we are base 64ing the string, so that's interesting to know. And another interesting point here is that it's actually telling us that there is some incorrect padding in the word of crypto. That should probably hint you toward pad oracle, and we'll see if that's actually correct here. So let's see first what happens if we do 0 0 0 0 1 1. IV must be 16 bytes long, and we have actually the cipher here. So we know that it's going to encrypt our message in blocks because it's using this mode CBC. The block size is 16 because it's actually telling us that it's 16 bytes long, and it makes sense with a 128. Looks like because we have 2 2 3 3 4 4 5 5 6 6 7 7 8 8. So if I do this, I do have that, and now if I do 16, I still have that. But if as soon as like I go over the 16, I'm having an incorrect padding. So looks like the 16 first characters are the initial vector, and that's basically telling us when the padding is wrong. We also know that the code is replacing tildes with equals and given mark with slashes and minus with pluses. That's a good thing to know in the different algorithm. And the identifier is basically base 64 encoded. So what can we do with all of that? After a quick search on internet, I end up like choosing one of many different exploit scripts for the padding oracle, and I'm basically pulling that one, which has an exploit. And what needs to be done with this exploit is basically just, if you scroll down, the usage is you have to provide the cipher, which is in our case it's going to be this one, and So this one is basically our cipher, and we then will need to have the length of the blocks, which identified to be 16 because of the error message that we got. The host will be a host, and the URL is going to be the path. So here it will be /post, and we have no cookies. I don't think we need a cookie here. Yeah, we don't need a cookie. And so based on all of that, the only thing that's remaining is, because we have now an error that is telling us, sorry, when we don't have the right padding, we need to provide this information. And it's literally the error we had before, incorrect padding. So if the response is containing padding, that means the cipher that we're trying is in our inner. So now that we have all this information, we could just go and craft our command. So here is my cipher. Let's go here. Tools, pad, Oracle attack, exploit.py, and I will run Python first. Then we said -c for the cipher. And now that I'm looking at it, there is a small change that we need to do, because the cipher as we saw it here in the run, it's going to be taken as is, where in our the, the, the Pastebin stuff, it's actually converting it. So what we need is to convert the same way. So we need to get that before with the cipher. So we need to basically take off the tildes, the slash, exclamation mark, and the minuses, and convert them to the correct thing. So I've done this here. So exploit.py is going to be, with this small change, we can now run the command, which will be this one, -l16 -host, doing here -u -u slash post equal, and the error flag would be padding, and I want to be verbose. So I'm going to also escape. That's true. We need to escape the animation there. Up, up, and up. see. So we are going to change it back to single quote instead. So that's it. We're pasting it. Okay, because it doesn't really work the way I think it's working, we're going to set up a proxy and look at the queries while it's running in order to understand what's happening. So loading a proxy on 8080 code by itself is basically loading this one and setting a host. Okay, so if we run now our command and looking at what is there, we have padding exception. If we now print the actual URL that is running every time, looks like it's valid. So what's wrong here? So I had to recreate the decryption logic for pad after looking at padbuster.pl because the previous one wasn't really working. So the idea here is to provide the endpoint and the cipher. We are doing the logic we have seen before on the cipher, and for each blocks we are going to try the padding by trying to find the perfect candidate for the block. And once we get back, because we will have the padding oracle that will tell us if we have good byte or not, we'll be able to identify the correct block of bytes for that first block size, and so on until we do 16 blocks. And once that's done, we would have technically the decrypted version of that cipher. And so when I run it here, we can see that the different iteration started to flag the different entries, and we saw that the first part was already kind of showing itself. The flag is the first part. Overall, we have the flag here, which, as you will see, should be valid. It is valid. And the second part is for the next flags. So when we see this kind of entries like JSON with like ID equal to and then a key, the fact that we see this ID equal to is basically saying, okay, maybe we could try to find the ID one, or at least try to get an IDOR for that thing. So the point would be, can we like do the other way around and encrypt our JSON with an ID1 and therefore doing an IDOR for it? So to sum it up a bit, what we want to achieve is basically having our some kind of JSON that will be possibly like ID called 1, and we would need to split this JSON into blocks of 16 bytes each and use the padding algorithm to pad the last block and generate a random block after it, and then set that random block to be a variable for it, and then still doing it. So what we will have at the end would be some kind of like um, text equal block 1, block 2, block 3, up to block n, and where the block n is padded, and our last block will always be the random one. And so because of how it's working, we need to find ciphertext that when it's XORed with the value of the last block, it will result into the plain text that we would choose. And once we have the correct ciphertext, we then repeat the process until we get the entire JSON. So it's kind of iterative, and the point is that we are still using blocks of 16 bytes, I mean. So we want to have the plain text divided into 16 blocks. And for each of these blocks, with like starting by the last one, we want to find a block that will provide us with the correct plain text. And so once we've done that, we switch to the next and the next and the next and so on. If I run my encrypt now, what it will do, so let me clear that. So what I want is encrypt I, and the endpoint would be the one that is here. And the plain text I want to achieve, as mentioned, is literally having this one. So ID equal 1. If I start running this, we do have one that is appearing. And so if we use that one specifically on the post, oops, my bad, I copied the wrong, copy select. Okay, this time we have attempting to decrypt page with title flag, and that gives us the third flag that is corresponding to our IDOR. However, we need to have a fourth one, and here we have decrypt payload post key as like a key index of the post, and body. And so here the key is wrong apparently. So what we could try, so first let me just verify it's the correct one. Correct, yeah. So what that is telling us, it's basically telling us that we were able to try to decrypt the page, but we're missing something. So usually when you have an ID, you should try IDORs, of course, but also, you know, see if you can uh, add an apostrophe and make sure that you don't have like SQL injection and something. So here um, we could try to see if this ID is taken somewhere. where we could trigger another vulnerability. And so we would like to see, and so ideally we will have to switch the quotes, oops, and we want to have the apostrophe in it. And so now that we want to have this, the idea is to see what happens if we provide the apostrophe as an ID. And actually, I think I messed up because should have been directly apostrophe and not just, okay, it was fair enough. So now we have actually a SQL command that is using directly post ID in it. And the fact that we are using apostrophe, it's telling us that we have SQL syntax that is wrong in there. So we want select title body from post where ID equal whatever. And it seems that we can enter that thing right away. So one way we could get more information would be to identify what kind of request we could do here. So you remember nothing is saved on the database per se, at least the data of the body is not supposed to. Um, so let's see first what tables we have. We see that we have a post. What we would like to see happening is something like a request that will do select equal null union select, and we should probably look at the database first. So what are the tables on top of post or among posts that are available to us? What I like to do for that, because we only have two column that we can use, so we only use one for now, and I'll be basically concatenating all the table names from the information schema tables table. And so this will allow me to see all the tables name from this database. So tables where table schema equal database. Yes, database. And so this, or more precisely, this should be set. So what I want is to have ID column this. So let's see what is the generated version of this. Union select group concat table name as title, null as body from information schema. Oh, I did make a typo. Tables, blah 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 blah, and that's better. Okay, seems like we have a candidate for cipher. Switching the posts, and we seem to have posts, which we already knew, and tracking, which is a new table. So what will be the content of tracking? Tracking makes me think that maybe there is some analytics that will be pulled. So let's look at that. So want to do basically the same thing here. However, instead of table, we want to, oops, we want the column this time. So column name, column name as title, nothing as body. This time it's from columns, columns, where it's not the schema anymore, it's the table name that is going to be, it's going to be, we said tracking, so tracking. Okay, so give me all the columns and concatenate them as a reducer function, aggregate function, and put it into the title and nothing in the body for the columns and go for it. Yes, looks like it's good. I'll remove that part and set it to what I just copied. And wait. Okay, so now that we have this one, let's see what it says. Headers. Okay, ID and headers. So we should basically see what's in the headers from we can pull it directly now. Yes. And so waiting again. Okay, we got a new candidate. And okay, we have a referrer, user agent, blah blah blah. Okay, from 14.8 to 7. Okay, okay. What happens if we do use this post ID and we got the new flag, which is valid. There we go. We managed to do some encryption, decryption for payload that will then be leveraged into an IDOR and then after SQL injection, and we got our full flags for it. Congratulations. Take care, everyone.